So we're going to continue on with section 8.4, which is called angles of elevation and depression. We're going to see some word problems here. Not a ton, but we're going to have to be writing like explanations in sentence form. So we're not just simply going to be calculating values. The first thing we need to be able to do is explain the difference between angle of elevation and angle of depression. The second thing is use that to determine requested values, and we're going to be working with elevation and depression in order to do that. So the first thing we have to do is we have to get some vocab down. So what I've done here is I've made a cute little picture for you with Curious George, and he's swinging in a palm tree. So our two different vocabulary words are angle of depression and angle of elevation. So the angle of depression is going to be, if Curious George's line sight is this horizontal line right here, the angle in which he's looking down at the man in the yellow hat is the angle of depression. Then you also have an angle of elevation, which is if the man in the yellow hat has his line of sight right here, this horizontal line, then the angle at which he is looking up at Curious George is the angle of elevation. So depression is angle down, elevation is angle up. So let's look at an example here where we need to identify angles of elevation and depression. You have this picture here, which is just of a hot air balloon, and they've got their angles labeled 1, 2, 3, and 4. So my two examples that I'm going to do for you are writing the description of angle 1 and also angle 4. So if I'm looking at this picture, angle 1 is this angle right here, which I see is an angle below a horizontal line, and it's from my bird looking at my hot air balloon. So I know that this is angle 1 is an angle of depression. From the bird to the hot air balloon. Then if we also look at angle 4 is this angle right here, and I see that that is an angle above my horizontal line, so it is an angle of elevation, and it's looking from the base of the mountain up towards the hot air balloon. So angle 4 is an angle of elevation from the base of the mountain to the hot air balloon. So as you can see, we're writing like sentence explanations here. It's an angle of depression from the bird to the hot air balloon, or the angle of elevation from the base of the mountain to the hot air balloon. Then you have two you-try problems where you're going to be looking at angle 2 and angle 3, which is this angle here, that's angle 2, and angle 3 is this one here. Now another problem we're going to look at is how do we actually calculate some values? So we're kind of blending angle of elevation and angle of depression with the trigonometry that we've been doing in the last section. So here they've given you this picture, but they also give you this word problem. The word problem says, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation from the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So if you draw on this triangle here, you know that you're standing 53 feet from the wind turbine. So you know that that side's 53 feet. And they also told you your angle of elevation, so going up, is 56.5 degrees. You want to know how tall is the wind turbine. Now, I only have this side of my triangle to complete it, but technically there's still this height here, right? So I need to figure out what that is. But they tell me my eye level is 5.5 feet above the ground. So this distance here is 5.5 feet. So let's go ahead and let's label that in our picture as well. Got 5.5 feet is this distance here. So now if we go ahead and we do some trigonometry, standing at this degree, this angle here, I have information about my opposite and my adjacent. So opposite and adjacent means I need to use tangent. So if they set this up here, tangent of 56.5 equals x over 53. And then because my x is on top, I multiply these two things here, giving me x equals 53 times tangent 56.5 degrees. So you should definitely be able to figure that out on your own because we've done that in the last section, which is the material we covered the last few days in class. Now, in order to put that into your calculator, you should hit 53, tangent, 56.5, enter. But remember, if your calculator works differently, you may have to go backwards. You may have to enter 56.5 tan times 53. If you're using the same calculator we use in class, you do it this way, and your answer is 80.07, which is approximately 80. Okay, so that tells me this length is 80. So let's go ahead and put that in. This length then is 80 feet. But we also had the 5.5 feet from our line of sight, the height to our eyesight. So the total height of the wind turbine is 85.5 feet tall. So what we had to do is we needed to combine our knowledge of angle of elevation with trigonometry to determine this problem. You're going to do that same thing here. You're talking about a plane needing to land on the runway at the airport. So you're going to have to plug in your values. They give you the word problem here, and they give you a picture. But you're going to have to go in and put in some other values and then actually calculate using trigonometry what they're asking you to find. Okay, so to the nearest tenth, how far from the runway is the airplane at the start of this approach? So that is your You Try problem, and I will see you in class.